thank you for giving this opportunity. I think TechWorks. Yes, I'm Saket, and I am the founder of Secure Elements. And I think there's this one reason I think which just like to strongly underpin today that we are at a cusp of some critical innovations by using Gen AI. And I'll show this to you. So what we did was, as part of our let's say growth strategy, so Secure Elements was founded in January 2022, and with the mission to help shape the automotive cybersecurity space, which is system-led and that is safe and secure. We are building software products mainly around risk assessment, software bill of materials mentioned by my previous speakers, security operations center. And as part of this building exercise, we then decided to go to, this is running fast. So part of that journey was basically applying for this Innovate UK funded, managed by Bridge AI Fund, to actually conduct a feasibility study using generative AI for automotive cybersecurity threat modeling. And I'll come to the problem statement in a bit. So this is the, sorry, I'm just bad with the because over here. So yeah, 50,000 grant funding, Innovate UK projects just literally completed end of March. So freshly new was a collaborative project between Secure Elements, Swansea University, I think Professor Zhajeng is here, and obviously ASIN, so Kani is here as well. So I think John described this very good early in his start. So typical Gartner hype curve. So one around generative AI, which is on the right-hand side. So speaking about 5 to 10 years of coming to the slope of enlightenment, and then one on the left-hand side, which is speaking about AI and autonomous vehicles. Right. So what has typically happened is the transition from human-led driving, so we are all driving today, will soon convert into automated systems driving, will lead to a scenario where systems are not secure, they're not safe, and that will put pretty much all of us and including the vehicle producers at risk, increasing substantial safeties, and the kind of liability risks. And the results are actually, I think the market perception and the how cybersecurity has evolved over time is very significant. Left-hand side, you see companies being affected by cyber attacks. We see an increased amount of attacks happening on remote servers and using that as an attack entry point into our cars. These are some headlines making articles. So one is a remote Jeep being hacked. Hackers attacking Tesla software. They're able to change it over the air, by the way. UK halts a sale of, I think this was an electric charging company that took off, I think, some vehicles from the grid because they feared a cybersecurity attack. So the point being that it's very relevant in the context of what we're doing today and how the automotive sector is evolving. So apologies why this is not there, but what I'm trying to say here is that all of these attacks taking place, so the government, the industry body, and academics came together to launch an initiative in the form of a standard and a regulation. So we have Regulation 155, which is fairly new to the automotive sector as we speak, which mandates implementing cybersecurity controls in a vehicle to be able to sell cars in the market. So starting July 2024, if you're not able to certify your vehicle against those requirements, companies can go bust and basically stop selling the car, putting the full stop. So there's no if and but. On the right-hand side, you see two classic examples of this regulation. VW has killed its e-up project because they think implementing cybersecurity controls on traditional vehicles is not happening, and therefore they have decided to stop funding the project. And likewise, Porsche Mechanics, so they have decided to drop the project because implementing cybersecurity controls on legacy cars is an incremental, monumental financial challenge for the business. Right, so the problem statement of the feasibility work that we were doing were mainly threefold. Going forward, basically To satisfy the Regulation 155 requirements, an organization has to typically conduct some kind of risk assessment to managing vulnerabilities and make sure that those are done at regular intervals, not just at one point in time and then you move on with the product development life cycle. So most of this work today is done in our beautiful Excel files from Microsoft, which is good for some categories. But I think moving forwards, as the regulation demands, that the onus is on the OEMs and the tier ones and the supply chain members to keep this for the next 15 to 20 years, because a typical vehicle lives its life cycle for roughly around that time frame. I think my previous speakers mentioned about lack of experienced personnels, labor in this area, who are not knowledgeable enough to conduct risk assessments themselves. And thirdly, that a typical vehicle has roughly around 60 to 70 electronic control units. Now, conducting risk assessments in an Excel file on 70 odd ECUs per vehicle for 10 vehicles down the line, imagine the complexity and the burden. And this is where Gen AI can actually come in. So what this does is that the risk assessment, so TARA basically stands for Threat Analysis and Risk Assessment as derived from the ISO standard. What this does is that the risk assessment becomes more static document in an Excel file with static number of assets, some attack vectors. There's a lot of manual labor required to actually conduct these type of experiments, and which actually means that the TARA document in itself is incomplete in nature, which at the end of the day would lead to some kind of attack vectors possible, because a human mind can go to a certain extent to apply some kind of security controls, but then cannot predict what's happening next. So therefore, this is a typical threat and risk assessment as done by or as published by the ISO standard. So we are the aspect of this project we're focusing on two main areas. One, how can we leverage generative AI to generate threat scenarios and mitigation strategies. So we go from asset identification to a few things. Mainly the focus is around how can you generate meaningful, contextualized, system-driven threat scenarios, and then at the same time being able to point out to a mitigation strategy or a security control. So firstly, this presentation is around divided the presentation around three different aspects. So one is around the detection aspect, the next one is around a bit of training, and then the next one is about integration and how we can actually use of it. We searched internet globally. We found 5 data sets, out of which this was one of the most closer, let's say, data set which contains, which was conducted on a dynamometer, not on a vehicle, had representative types of attack types, so fuzzing, spoofing, and masquerade attacks, and the confidentiality property, authenticity, integrity, confidentiality. The data set was recorded for 30 minutes, containing 106 ECUs, and then 13 types of attacks captured as part of this. So that's our basic model of how we envisaged, or how we basically started detecting an attack type using the raw data set. But basically, we used big sequencing, analyzed the CAN payload, CAN ID change, injected that through our tool chain from Crystal, which is able to generate some attacks. Added that as a noise into the training process, used commonly used term as BERT, or a bidirectional encoder language in LLM, to be able to generate a meaningful sentence out of it. Typically, the process looks like this. So you have a CAN data frame, 8-bit payload, having CAN ID. So we used BERT as a means to identify the next CAN ID logical sequences, to be able to then use a method called a sentence pair modeling, where if I'm able to identify a sentence and break it into different chunks, so if A, B, C, D, E, so if I can break it down into A, B, B, C, D, E, I can logically understand what's coming after and what's coming, what has happened previously. And therefore, I was able to identify the CAN ID change logically happening in that training data set. And that meant that, this was the output or the result of our training exercise, which actually achieved an accuracy of, in the F1 score is around 90%, which was not too bad actually in the first go. But the problem comes when you start using LLMs or OpenAI. I'm not speaking ChatGPT, by the way, I'm speaking OpenAI. Right. If you start writing threat scenarios using our tool and sending it to OpenAI, that started generating non-contextualized data, not meaningful. As a security analyst, I wasn't able to understand what it actually meant. So you can read it for yourself. So I inputted a text, and then the generated scenario by OpenAI was meaningless to me. It didn't mean anything to me in the first place. Right. Output, incomplete threat scenarios, random in nature, there was no context, useless to me. Next up, we compare the different services or the different applications out there, including GPT, OpenAI's, LLMs, We purposefully chose, I think it was ChatGPT Turbo 3.5, which is the latest of the models by OpenAI. Purely because having analyzed these 4 types of models, Llama, Claude, Gemini, OpenAI was the best suitable application for us because it's open source and not closed environment like Llama or like Claude. The next task was basically using this chain of events. So we entered inputs from one of our security applications. That went to an OpenAI library that was able to do some prompt crafting, send an API request. Now what we included was a GPT 3.5 Turbo plus a method called as retrieval augmented generation. Now that's a fairly new concept. I think a chap called Patrick Lewis in the US, an ex-Facebook guy, invented this, let's say, technology, or this type of, let's say, algorithm where LLMs fall short. Because remember that OpenAI has been trained on a data set which is roughly 2.5 years old now, or maybe 1.5 years old. How does the LLM keep up to date? I think using one of these methods of retrieval augmented generation, goes out, fetches online, let's say, real-time data from the internet, makes it available to the GPT service, to the Turbo model, combines that with the input text, and then and then generates an output. Now, using this method, compare the same scenario that we fed into the system, and now you can see that we were able to generate not one, but tens of threat scenarios that were, first of all, complete in nature, which were making sense to me as a security analyst, having done hundreds of risk assessments before myself. And then it's system-driven because we fed the Turbo model plus the RAG with a system holistic input. And that's where we brought in call it the validation of the training and the validation concept at the same time. It's good that we have good amount of threat scenarios generated, but hang on, how do we verify or how do we validate that those scenarios can be compared against Regulation 155? Bear in mind that regulation has an Annex 5 table which lists baseline threat scenarios that an automotive company should consider while doing the risk assessment, and that became our validation methodology. So we compared that using this model where we fed in the Annex 5 document to the model, a PDF standard document. We used one of our inputs driven from the system. We again used a methodology called ANN, or an approximate neighbor, nearest neighbor concept, to then let's say decode what could the generated threat scenario relate to in the Annex 155 document, and that resulted in giving this particular bottom line statement, the manipulation of electronic hardware, etc., which actually meant that our model was not only able to generate scenarios, but using this method, it actually came very close to pinpointing exact attack type mentioned in the regulation document, which is good enough for us. But not only that, using this, we were able to identify a mitigation measure, again listed in the 150 in the regulation document, which actually means that GenAI could be used when it is fed using context-driven data, and this is what I showed in my next video. So this is our application. On the right-hand side, you see some API responses. So we fed the model now with a system name, the asset name, the security objective, some cybersecurity properties, Annex 155, threat type, threat scenario description, and the result was absolutely promising. So this model has now been integrated as part of our risk assessment application, and is now able to generate a meaningful context-driven response, which actually saves a lot of, it will save a lot of time for security analysts and engineers who are conducting day in, day out, risk assessments on those 60 or 70 issues that I mentioned before. So again, you're coming to the conclusion statement. So again, I started from saying that it's more Excel-driven, the problem statement, and this is where it now kind of ends, that yes, we are able to use GenAI text-based Tara applications or Tara tools. Lack of engineers can be supplemented, or let's say can be comprehended when we introduce AI and LLM type of applications, because that would aid, not stop. And thirdly, it reduces labor, time, and cost, which is what a company actually wants. So you can see the stark differences. And to be honest, I didn't see this project was started as a feasibility study to underscore it's feasible or not, but it actually integrated in our application. So it's more than just a feasibility study, actually. So some challenges that we have come across, mainly around limited training data, as I mentioned. And this is going back to the point that we need organizations to basically work with us to make sure that that model is accurate. How can we enhance the efficiency of that model? Because remember that this has been trained using one open source data set. Not sure how representative that is in the context of real world driving conditions. Of course, this was a feasibility study. 6 months is not enough. Then we have, I think one of the critical points is GDPR and privacy. How do you make sure that these models address confidentiality? How does one ensure that if my application is being used by an OEM versus a tier one, how can I make sure that these models don't interact with each other? So that level of confidentiality is one of the challenging things that we are yet to address. Again, careful section of LLM algorithms, and finally access to real world vehicle data. I would end my slide by saying that we have some good achievements out of this project. So this project was actually successful at the ITS World Congress 2024, which is scheduled to be in Dubai later this year, and our paper has been accepted. We ran a LinkedIn campaign to collect industry responses of how generative AI could actually solve some of the problems in the space of automotive cybersecurity risk management. We are still collating the data. The campaign has stopped, and that response will be published as part of a white paper. And then finally, this is our TechWorks/ASIN plenary session that we held, I think, just about a month ago. I think that's it. Thank you.